Hi, my name is Kyle Andres, and today I'll be going over EE178 lab number 7. So for this lab, we need to design an FSM to control the data path of a speech synthesis circuit, and we'll be utilizing the SPO256 to accomplish this. So I'll be doing a quick explanation of the code for this lab and show the FSM as well as the block diagram. And yeah, the narrator is the top level design of this lab, and it sends the data to the chip, and it uses a counter system to sequence the phonemes, and it's programmed to say my name. And this module also drives the chatter module, which is responsible. The chatter module is responsible for um, taking the data from the ROM or the read-only module, and this is also responsible for driving the the DAC, the data converter submodule, and the FSM. And this is just responsible for turning the signals into a PWM. And this is the FSM. So we have an output busy, input period expired, data arrive, val match, and also an output of load pointers, the increment, sample capture, and clock. So as for the input, we have the data arrive, which checks if there's a new data coming in or new phoneme available. And the period expired is responsible for controlling the sampling rate. And val match is pretty much checks if the playback is the phoneme is complete. And as for the output, this checks if the system is active. For the load pointers, it checks or initializes the new phoneme pointers. As for increment, it moves to the next sample, and sample capture just reads the data from the ROM. And these are the states. So for idle, this just waits for the new data, and once the new data comes in, it loads, and once the once that loads, we have a 2 clock cycle wait for this is because the SPO256 requires 2 clock cycles of wait time. And the capture just reads the data from the ROM, and again, sample wait just waits until the next sample, and then increments it increments it to the next memory address. And these are the states. So for this one, the idle, we wait for the idle, and sorry, the idle waits for new data, and once the data arrives, it loads, and once it loads, we have a 2 clock cycle wait time. And after the latency clock cycle wait, it captures, and if the value matches, then it goes to idle. But if it doesn't match the value, then it goes to sampling wait. So in the sampling wait, this just waits until the next sample time. So the period expired, so it keeps looping. And if the period expired, then it increments it and goes back to and loops back to wait one. And that's pretty much the control system, the control. Here, let me show the output. So let me just auto connect the blackboard. And once I connect the blackboard, I'm just gonna program it, and should be able to hear my name. And yeah, that'll be it for lab number 7. Thank you.